Okay, we started the atomic spectrum last class में. Atomic spectrum में emission spectrum. When will be the emission spectrum? When the electron jumps from higher energy to the lower energy, that time it will emit the wavelength. That wavelength formula we learned, right? 1 by lambda wala. Okay. Based on that, we are doing the questions. So this is the formula we have to use. 1 by lambda is equal to r z square into 1 by n1 square minus 1 by n2 square. N1 is the lower energy, N2 is the higher energy. And already third excited state means N value is how much? Third excited state, N equal to 4. Second excited state means N equal to 3. Excited means one extra bolne ka, that's it. Right? So then only when it jumps from higher to lower only, it will emit the radiations always. From that only we get different types of series will get Lyman, Balmer, Bulke. Okay? Chalo. Karo. Until answers. Calculate the wavelength of the photon emitted of a hydrogen atom. मतलब Z value is 1 when it falls from third to 1. So lower shell is 1, N1 is 1, N2 is 3. Lower shell is always number low wala. Lower energy level, higher energy level. Use and tell the answer. Thanks so much. Approximate also can tell.
Sir, we already did this question.
We done now this question?
Yeah. So 1024, right?
Oh, yes. And how many questions we done? Iske baad?
So we did this. Before that, we did hydrogen atom. Another question, then we did drawbacks. We're done with Heisenberg's uncertainty difference.
Okay, चलो. एक question क्या? You know?
No, sir.
No? Yeah,
No.
correct. Electron in a hydrogen atom first jumps from third excited state to second excited state. मतलब where से where? Electron is coming from where to where? Third excited state means n equal to 4 to second excited state means it is coming to 3. This is the first one. And then it is coming from second excited state to first excited state. Second excited state means 3 to first excited state means 2. इसका corresponding wavelength is lambda 1. इसका corresponding wavelength is lambda 2. He's asking what is the ratio of lambda 1 by lambda 2. Separately formula apply करो, divide करो, and you'll get the answer. करो. These are JEE questions only. Use the formula 1 by lambda formula. Don't substitute values R and this one. Hydrogen atom Z is 1 only.
It's 20/7.
By 7 is answer. One by lambda 1 is equal to R Z square is 1 into 1 by N1 square is 3 square is 9 minus 1 by N2 square is 16. First equation. Second equation is 1 by lambda 2 is equal to R Z square is 1. 1 by N1 square is 4 minus 1 by 9. So if you divide, we'll get the answer as 20/7. Okay. Next. Karo. In a hydrogen like atom, atomic number is 1. When an electron jumps from M shell to L shell, KLM, 3 to 2, right? First case mein 3 to 2. Iska wavelength is lambda, I told. Okay. If the electron jumps from N shell to L shell, KLMN, 4 to 2, the wavelength of the corresponding lambda dash is how much? Same thing. इसका equation use करो, divide करो, you'll get the answer.
20/27 lambda.
डूइंग कुछ कर रहे हैं करो पापा और करने दो उसको ही इज पुटिंग द पेपर एंड टेलिंग आंसर how many marks you're getting in college में total out of 300 नहीं बोलेगा ओके
Rarely I had any exam sense only.
ओके चलो clear हो गया see here also 1 by r 1 by the lambda value here also 1 by lambda dash value okay z is 1 so just divide you will get the answer is 20 by 27 lambda now spectral series है spectral series आपको मालूम है ना spectral series में क्या क्या series है tell me what are the different types of series याद है Lyman, Balmer, Passion, bracket, P fund. Okay, so these are things. But देखो this is the spectral series लिखो. Lyman series. When the electron jumps from where? Second, third, fourth, fifth से one तक गिरेगा तो it is कौन सा wavelength आएगा? UV का wavelength आएगा. This type of series is called Lyman series. And Balmer series is all electrons only. Electron jumps from one shell to other shell. Wavelengths are coming. They studied. Balmer is very famous, which is visible, which we can see from third, fourth, fifth to second shell. We can call visible. And passion will be near infrared. Bracket is infrared. P fund is far infrared. Semiconductors, if you understood, we can remove the chapter for semiconductors. Later we'll start the papers from ending of the November. Digital circuits understood? Digital circuits, these all things no? अरे चलो जल्दी करो हो जाएगा चल now देखो you understood this one you have to by heart by heart करो Lyman Balmer Passion bracket P fund by heart करो and 1 2 3 4 5 higher to always first shell वाला कभी भी Lyman वाला हो गया by heart करो until भी सात्विक Lyman
And Balmer partial bracket refund.
okay and bracket वाला which region
Fourth.
But the region means this one you should tell which one
Infrared.
infrared near infrared infrared far infrared we have so totally we have 5 only near infrared infrared and far infrared this one okay chalo now we have this one already now dekho suppose I'm talking about n equal to 2 to n equal to 1 suppose electron jumps from 2 to 1 find the value of lambda find the wavelength by using that formula for hydrogen find the lambda when electron jumps from 2 to 1 here's a conclusions aayega some conclusions we'll learn
1214.6.
Okay. So 1214.6 something angstroms. Okay. Now second one, 3 to 1. Find karo, lambda.
So 1024.
Approximately 1024. Okay. Angstroms. Now infinity to 1. Like from infinity to 1 it is. Kitna?
911. 911.
911 angstroms. Matlab here one conclusion should be coming. देखो, which is a larger transition? Larger transition कौन सा है? Like 2 to 1 or 3 to 1 or infinity to 1. Larger transition is what? From infinity to 1. Larger transition is having smaller wavelength. Conclusion understood? See, larger transition will have smaller wavelength. Smaller transition will have larger wavelength. There's a thing. Very much. We are talking about Lyman ka. Lyman, देखो, all higher to 1 only it is falling, right? Lyman series ka. Lyman series, larger transition will have smaller wavelength. Smaller transition will have larger wavelength. Okay, that is very important. So, लिखो, smaller transition will have larger wavelength and larger transition will have smallest wavelength. सो N1 N2 आपको डिसाइड करना पड़ेगा. That is the thing. फॉर्मूला तो सेम है, एक ही फॉर्मूला है. वेरी इंपॉर्टेंट फॉर्मूला. सो मेनी क्वेश्चंस केम इफ यू आई अपलोड, राइट? आई अपलोड सो मेनी क्वेश्चंस दैट ओनली फॉर्मूला, सेम फॉर्मूला ओनली. बट द थिंग इज N1 N2 आपको डिसाइड करना पड़ेगा. नाउ टेल मी, ओके लिख दिया. यू नो सीक्वेंस, दैट सीक्वेंस शुड बी नोन. बाल्मर, पैशन वगैरह. ओके. सपोज इफ आई आस्क लॉन्गेस्ट वेवलेंथ ऑफ बाल्मर सीरीज, फाइंड करो. N1 N2 क्या लेगा? लॉन्गेस्ट वेवलेंथ मतलब smallest transition you should take. So N1 is how much? 2. N2 is 3. करो, substitute करो. Tell. Find the longest wavelength of Balmer series. So longest wavelength has smallest transition. Balmer to N1 is 2 only, and N2 is higher cell is 3, because smallest transition will have longest wavelength. Find करो, substitute and find lambda.
1639.
No, wrong. abacus में मत करो.
So 6559.
says it 1975.
1975. No wrong. 1 by lambda
Six
is
five.
equal to 6552, approximately 6552 angstroms. Okay, r z square into 1 by n1 square minus 1 by n2 square. Okay, so करके we have to get the 1 by r value लिया तो 911 आएगा, इसको solve किया तो 6552 angstroms. So they will ask this one longest wavelength, shortest wavelength. So transition, that series you have to know. n1 n2 values नहीं है वाले तो you cannot do any question. बार वो sequence you have to by heart. Okay, चलो मैं करो. Taking the wavelength of first Balmer line, मतलब first Balmer line means 3 to 2. Lambda they given as 660 nanometers. And the wavelength of the second Balmer line, मतलब 4 to 2 will be how much? Will comparison से बोलने का. Okay, do and solve. Options will give. So first lambda 1 ले लो और लास्ट में सब्स करेंगे. lambda 2 फाइंड करो, डिवाइड करो, लास्ट में lambda 1 सब्स करो. कंपैरिजन से we should say. So first one it told 3 to 2. इसका वेवलेंथ lambda 1 मान लो. Now find the lambda 1 first. R z square into 1 by n1 square minus 1 by n2 square. First equation, ऐसा रहने दो. First equation. Last में lambda 1 you can substitute. And second 4 to 1, 4 to 2 means again 1 by lambda 2 is equal to R into 1 by 4 minus 1 by 16.
Sir, option B.
Option B. 388 point. Shura, mains question.
Yes, 488.9.
अरे B you're telling, D only telling, yeah? हाँ, yeah, correct. या मच कुछ ऑप्शन नहीं दे रहे वो लोग, वो पास पास कर रहे हैं. आई डोंट नो व्हाट यू एट सात्विक टुडे. ओके, तो फास्ट में बोल रहे हैं और सिंपली डायरेक्टली स्टार्टेड बाय हैडिंग फर्स्ट क्वेश्चन दिस आंसर दिस आंसर दिस आंसर, राइट. ओके, सो डिवाइड करो, ये दोनों डिवाइड किया तो यू विल गेट द आंसर. चलो नेक्स्ट. कुछ नहीं, इसमें डिवाइड किया तो कैंसिल हो जाएगा, आर कैंसिल हो जाएगा, कैलकुलेशन पढ़ करो. हाँ करो. The wavelength of the first spectral line of the Balmer series. First spectral line means 3 to 2, right? Balmer series ka 3 to 2. The wavelength, corresponding wavelength is 6561 angstroms. The wavelength of the second spectral lines of the Balmer, same thing. So 4 to 2. Lambda 2 is asking. So comparison se we should say. Again form the equation and solve and tell the options.
Sir, option C.
No wrong. Last में substitute करो. First 1 by lambda लगानो. Last में when you're dividing substitute.
So option D.
ऑप्शन डी है नो कम ही आएगा भाई 1/λ1 इज इक्वल टू r इंटू 1/4 माइनस 1/9 सिमिलरली बाई 1/λ2 इज इक्वल टू r इंटू 1/4 माइनस 1/16
Yeah.
हाँ
I forgot to do with helium atom.
हाँ yeah hydrogen atom right and this is single helium atom it is 4 right करो divide करो first one is hydrogen they given that's why Z is 1 लिया helium atom लिया second one 4
Option 1. Sir.
yes 1215 angstroms okay see Shyam helium is atomic number is कितना atomic number is 2 उसका उसका 2 square is 4 so r z square के जगह में 4 first one is hydrogen atomic number is 1 that's why 1 डाल दिया कैंसिल करो r कैंसिल करो if you do reciprocal lambda 2 by lambda 1 के जगह में सब्सिट्यूट करो ये वाला and LCM लेके सॉल्व करो you'll get answer 1215 these all JEE mains questions are there okay now number of transition or number of spectral lines I want number of transitions or number of spectral lines suppose मान लो it is electron is doing transition from 3 to 1 so 3 to 1 okay how many ways are there to come to 1 one is it will jump from 3 to 2 then it jumps from 2 to 1 right second one is it can directly jump from 3 to 1 these are the ways so how many ways are there 1 2 3 so number of transitions number of spectral lines can come is only 3 spectral lines if I ask for 5 to 1 or 7 to 1 ऐसा कुछ पूछे तो it's difficult to calculate always difficult to calculate that's why there is a formula write down number of spectral lines is equal to number of spectral lines is equal to n2 minus n1 into n2 minus n1 plus 1 by 2 oh, this is the formula n is the higher energy level n1 is the lower energy level suppose मान लो 6 to 2 calculate how many spectral lines higher is 6 and lower is 2 so 6 minus 2 4 plus 5 by 2 how many 10 spectral lines are there so like this we can calculate directly by using this formula n2 minus n1 into n2 minus दोनों same thing देखो n2 minus 1 plus 1 by 2 okay so these are the things in the emission spectrum next one is absorption spectrum ये तो कुछ नहीं है emission spectrum कब आ रहा है when the electron jumps from higher energy state to lower energy state एक certain wavelengths only coming not all wavelengths right only certain wavelengths only coming why I told you because only specific wavelengths only coming because energy difference is same like in Bohr's model में like याद है ना first shell में तब minus 13.6 minus 3.4 ऐसा so that's why we are getting only emission spectrum now देखो absorption spectrum क्या होगा what we're doing is it is spectrum obtained when white light or passes through the cool glass of solution of substance and certain wavelengths of light are absorbed by the atoms and molecules of the substance so what is happening I took a cool glass atom gases molecules are there inside I'm not heating emission में हम लोग क्या किया we heated heat करने से gas atoms excited electrons again coming back it is emitting but here what I'm doing is I'm taking a gas inside I'm passing white light that's it I'm not heating anything white light I'm passing so क्या white light is nothing but photons right so क्या होगा gas में gas these are gas atoms and that white light when it passing through the surface outside जो आ रहा है ना I am passing through prism करने से we are getting some lines only specific lines only ये स्पेसिफिक लाइंस कैसे आ रहे हैं मालूम है? जो एमिशन में मिस हो रहे हैं दैट इज कमिंग हियर. तो जो एमिशन में मिस हो रहा है दैट इज कमिंग हियर. व्हाई? व्हाट इज द रीजन? मींस these when I pass the light, electrons क्या होगा? Electrons getting the energy, if they get the energy a difference of energy level, then the electron will jump from here to here, right? Only if it get the difference of energy level specific, then only it will jump, right? So this atom जो भी light आ रहा है ना, light आके some electrons को hit कर रहे हैं, hit करके it is absorbing, this electron is absorbing that radiation, some of the radiations, and jump from here to here. Those radiations will not appear here, right? जो absorb हुआ colors and remaining will be coming there, light, and that उसका wavelength only we are seeing. Some are missing because of this absorption की वजह से. Okay, तो मैं so absorption spectrum में देखो only some colors, वो ये black जो भी है वो emission spectrum में है, that one missing. पकड़े तक? Yeah. Look at explanation. When a white light is passes through the cool gaseous element, the atoms absorb specific wavelength corresponding to energy difference between two energy levels of the electrons. So when they will absorb only energy difference, only they will absorb and they'll jump. Okay. That absorbed energy excites the electron from lower energy level to higher energy level, and the absorbed wavelength appear as a dark lines on a continuous band background. Dark lines we are seeing because that lines why missing, because it absorbs particular wavelength, absorbs particular wavelength, and we are seeing the dark lines on the continuous background. Done. Okay, by this your complete chapter successful done. Atoms ka done.